There we go. Does actually have a session now. Okay. So unit conversions. And what do I mean about these? They are ways to get from one physical measurement to another. They help in physical meaning of a measurement. They also can tell you unit analysis is a method to determine proportionality between measurements. And what I mean by this is are two values proportional linearly, inverse, square root, etc. So easiest way to do unit conversions sort of relies on fractions. So if I want to convert something, example, convert 3 feet to inches, I have to start with a proportion or a fraction that contains my original value, and I need to end it with inches. Now your goal is to end up with same units. And that's generally the goal. If you get the numbers wrong, you're going to get the question wrong, but ideally you're getting the units right and you're showing this process to get from step to step to step. So here I give a lot of space, but I didn't actually need it. So we know that 12 inches make a foot. So you can write this as 12 inches per foot, 1 foot. And I wrote this in the same way. I need to cancel out my feet. So the top, or the numerator, is going to cancel with the denominator. So I know I need to have feet in the bottom. Or I guess foot. 1 foot are going to give me 12 inches. I can just cancel out feet. 3 times 12 gives me 36. 1 times 1 is 1 equals 36 inches. And that's great because then we can, solve for other units, but how do we apply this in a sort of like a chemical intuition? So unit conversions are often between moles and some other value. This can be volume, this can be mass, this is typically what it is. Sometimes you can solve for molar mass if they give you like a unit lattice and they tell you the unit lattice structure and how many atoms there are. You can calculate for molar mass, but you need to know Avogadro's number. This is 6.022 times 10 to the 23 atoms per mole. This is can also particles, molecules, how many atoms are in 30, maybe I'll make this a little bit easier for me. Of oxygen, dioxygen. So you want to know how many atoms there are. So let's make my final answer, put a fraction here, in atoms. Okay, and I know I have 32 grams O2 divided by 1. So I need to get rid of grams on the bottom. I know that automatically. And I want to end up getting rid of grams, or I want to get moles. And for moles, I can go to particles or atoms. So I want atoms on top. I want moles on the bottom. Now I have to think about what numbers I can put in here. This number is molar mass. So our molar mass of oxygen is 16 grams per mole O times 2, because we have 2 oxygen atoms, is 32 grams per mole. You can see I did this in then I want to know how many atoms are in 1 mole of oxygen. This is just Avogadro's number. So I can cancel out grams O2, grams O2, moles O2, moles O2. I'm left with 32 divided by 32 times 6.02 times 10 to 23. So I'm left with 6.022 times 10 to the 23 over 1 atoms O2. Similarly, we can go from volume to particles or whatever we need to do. So let's say density of aluminum is, let's see what the density is. 2.7 grams per cubic centimeter. How many atoms are in a a 3 by 5 by 2. These are all in centimeters. Rectangle. So I can start by drawing the rectangle. And you have dot dot dot. So let's make this one 5 because this is the longest. And let's make this 3 centimeters, and we'll make this 2 centimeters. So I have to get from volume to atoms. So what I need to start with is centimeters cubed over 1. And I need to get from centimeters cubed to grams. So centimeter cubed AL. And this is 2.7 grams AL. And now I need from grams to moles. And I believe this is 13 point something. But I don't know yet for sure. It's 27. So I was way wrong. 27 grams. AL is in 1 mole. AL. And now I need to multiply, get rid of my moles. So I got rid of my centimeters cubed, got rid of grams. Now I need to get rid of moles. So 1 mole AL is in 6.022 times 10 to the 23 particles. And that is 3 times 5 times 2 is 15 times 2 is 30. 30 times 2.7 divided by 27 times 6.0322 times 10 to the 23. So I don't really know what this answer is, but I can give a best estimate. So 30 times 2.7 divided by 2.7, or divided by 27. Let's go calculator. 3 times 10 to the 22, or 6.022 times 10 to the 23 atoms. AL. So I guess I'll finish it up with some checks. Make sure units are moving in right direction. And what I mean by that is that if I have 10 to the, or 10 meters, should this be more in centimeters? And I know what you're saying, thinking centimeters are smaller, so it's gonna be less. But it's gonna grow because there are more centimeters than 10 meters. 1 meter is like this, and then you have 100 of these lines. Let's just say 100 cm. So this should get, oops. And I did the same thing again. Well,